Space is big. Like, really, really big. And it's also really empty. And because of that, it's really hard to get from one place to another. But there is this one thing, this one concept that has captured the imaginations of scientists and science fiction fans alike. Wormholes. The idea is simple. A wormhole is basically a shortcut through space, a tunnel that connects to distant points in the universe. Travel through one end, and out pops the other. Easy peasy. But there's a problem. We have absolutely no idea if they're even possible. A lot of people think that wormholes are just a fun sci-fi trope and that's it. They'll never work. But others think that they could be real. And if they are, here's why. They might collapse the moment you step through. First off, let's talk about how wormholes might actually work. The math behind them is pretty wild. It involves bending space-time to connect to points in the universe. This would require something called exotic matter with negative energy density. That's right. Matter that has a negative mass. This stuff would create a repulsive gravitational force that could keep the wormhole open and stable. But here's the thing. We have never seen this stuff in nature. It's possible that it doesn't exist, which means wormholes might not either. But let's play along for a second. Let's assume that exotic matter exists and we can create a what then? Well, the problem is that these things seem to collapse faster than you can blink. According to Einstein's equations, a wormhole is like a black hole with a throat, and just like a black hole, it has an event horizon. Once you cross that threshold, you can't come back. In fact, you can't even send anything back, because anything that enters a black hole or a wormhole is doomed to be stretched and distorted by gravity until it reaches a point where it is no longer recognizable as anything. So, if you wanted to stay in a wormhole long enough to actually travel through it, you would need to keep its mouth open with more exotic matter. Otherwise, it would collapse faster than you could say cheese. Not very helpful. Now, some physicists have suggested that wormholes might be able to remain open without exotic matter, but they haven't figured out how yet. They're still looking for solutions to Einstein's equations that don't require negative energy. Until then, wormholes will remain a beautiful idea, but maybe not a reality. So is there any hope for intrepid space travelers who want to take shortcuts through the cosmos? Maybe. Theoretical physicist Paul Steinhardt and his colleagues have proposed a new type of wormhole that doesn't rely on exotic matter. Instead, it uses a quantum effect known as entanglement. The wormhole remains open thanks to the connection between two entangled particles. But the team at UNT figured out how to make one of these wormholes any bigger than a trillionth of a meter across. So don't hold your breath. For now, wormholes may be more science fiction than science reality. But who knows? Maybe one day we'll find a way to make them work. Until then, we can always dream of what might be out there beyond the big crunch. Speaking of big crunches, don't forget to subscribe so you don't miss any of our future videos. Thanks for watching.